So this is an interesting concept. This uses the same ideas that we have been with solving trig functions, but we're going to be using a lot more of the identities. And so these use some of the more complicated identities, not necessarily ones that we used quite a bit. So I put them up here so you would have them. This one uses what's called the double angle identity. We're also going to use the half angle identity and some of the addition identities that we did as well. So solving this function, the very first thing we're going to do is we're going to get rid of this 3 cosine of 2x. Okay, now I'm going to do that by using the double angle identity. So I have 5 cosine x plus 3 parentheses. Now, cosine of 2x is cosine squared x minus sine squared x. All right, now I want you to remember that sine squared x is the same thing. Now again, we're using identities here. Right? This is a lot of steps. So some of you might be able to skip some of these steps as you go. That's fine. I'm going to do them all for you though. So I have 5 cosine of x plus 3. Now I don't want the sine. I have all cosines, so let's get rid of the sine. Cosine squared x minus 1 minus cosine squared x, okay, equals 3. That's using the basic identities. We know sine squared x is 1 minus cosine squared x. Okay. Now I'm going to simplify. I'm going to simplify all in one step. I hope that doesn't confuse a lot of you. 5 cosine x plus 3. I guess I'll do it in 2 steps. So cosine, we have 2 cosine squared x minus 1, because minus minus is plus, equals 3. Okay, I'm going to simplify some more. 5 cosine x plus 6 cosine squared x minus 3 equals 3. Now I'm going to move around so it looks like quadratic. Okay, I'm going to have 6 cosine x, or 6 cosine squared x, plus 5 cosine x, and I'm going to also subtract 3 from both sides. Minus 6 equals 0. Okay, so this is the first part. Okay, I've gotten to a point where now I can factor. Now I have to factor and then solve 3 major steps in this problem. These are long problems. All right, so now we have the 6 cosine squared x plus 5 cosine x minus 6 equals 0. We will continue by factoring. Now I'm going to go through it in depth on the factoring on this one because we had such a problem with it last time. So when I factor, I'm going to multiply a and c together. Now if you do factor a different way, use your own method. You don't have to do this. Negative 36, and I say, okay, what factors of negative 36 will add together to give me positive 5? Well, a 9 and a 4, okay? So I want a positive 5, so the 4 must be negative. So I'm going to rewrite now this in 4-part pieces so that I can group. 6 cosine squared x, that doesn't get touched. The 5 cosine x is now going to be split into plus 9 cosine x minus 4 cosine x. Okay, that became 2 pieces. Minus 6 stays the same, equals 0. Now I can group and factor. Out of this one comes 3 cosine x, and I'm left with 2 cosine x plus 3. Out of this one, oh, I did something wrong. Right here, I grouped wrong here. So this is plus a negative 4 cosine x. There we go. So that negative wasn't supposed to go to the whole thing. And I'm grouping symbols in the wrong place. Okay. So now I factor out a negative 2, and I'm left with 2 cosine x plus 3, 0. Okay. Now that I grouped, I can now factor out this piece. So I factor out 2 cosine x plus 3, and I'm left with this piece and this piece. 3 cosine x minus 2 equals 0. And now I have factored. That's my next second major part. So the first major part was I used my identities, then I factored, and now I'm going to solve. So we solve 2 cosine x plus 3 equals 0. 3 cosine x minus 2 equals 0. I end up with cosine of x equals 3 over 2, and cosine of x equals, oops, this is a negative, equals 2 over 3. Now this is less than -1, so there's no solution here. This is a calculator problem. Cosine 2/3 gives me 0.8411. And remember, this is plus 2k pi. Then I also need the negative version. Plus 2k pi. And now I'm finally finished. One problem, 5 minutes. Woo! That was intense. Okay, the next ones are not quite as intense. The last one is, but the next 3 examples are easier. Okay, so sine x cosine x equals 1. Alright, we're also going to use the double angle identities. Now, we're going to need to manipulate these just a little bit. Okay, what I want, I have the sine x cosine x. And I want to be able to replace it with something else. So, since this is 2 sine x cosine x, I'm going to make the assumption that I can say sine 2x over 2 is the same thing as sine x cosine x. And I can do that because I just divided this one by 2, so I can get rid of it. Now I can replace sine x cosine x with sine 2x over 2. So this becomes sine 2x over 2 equals 1. I'm going to get rid of the 2 on the bottom by multiplying both sides by 2. And I get sine 2x equals 2. Now, I would have to solve for u, I would have to put a u in there and all that kind of stuff. But before I even do that, I want you to look at the fact that this is sine of something equals 2. We know that's not possible because this has to be between -1 and 1. So this has no solution. We cannot go any further. All done. That was an easy one, yeah? Example 3. Okay, so this one is going to also use the double angle identities. That's cosine squared x minus sine squared x equals 1/2. So since we know here that cosine of 2x is cosine squared x minus sine squared x, okay, I can now replace this with cosine of 2x equals 1/2. Okay. Now I'm going to use the u, cosine of u, where u equals 2x equals 1/2. Alright, so where does cosine equal 1/2? Alright, it does at pi over 3. Use your triangles if you need to. So cosine of the inverse of cosine of 1/2 is pi over 3. So I end up with u equals pi over 3 plus 2k pi, and u equals negative pi over 3 plus 2k pi. Almost done. We're going to replace the u with the 2x and solve. Divide by 2, and I get x equals pi over 6 plus k pi. And on the same one, the same process here, it's just x is going to equal negative pi over 6 plus k pi. Okay, another one, fairly simple, okay, just a matter of plugging in the formulas and solving. Okay, next example. Alright, 2, now this one we're going to use the addition identities. Okay, this is a little more complicated, a little different. So it says sine 2x cosine x, cosine 2x sine x. Now, down here it has a sine x plus y. I want you to notice that these could be considered x's and y's. Okay, they're separate, 2 different values. So this is the same thing as the first one. Do you notice that? So I can replace this whole thing with sine 2x plus x equals 1, which is the same thing as sine 3x equals 1. So where is the sine of x? We're going to do the u equals 3x. So sine of u equals 1. Okay. So the sine of the inverse of 1, sine 1 is pi over 2. Okay. Now on your chart, it actually tells you when you have the 1, you can just have one solution. It's just pi over 2. You don't have to do pi minus. And that shows it on the chart. Because it's equal to 1, it doesn't have any other stipulations other than that. Because it's equal to 1, it's pi over 2. So I have 3x equals pi over 2 plus 2 k pi divide by 3, and I end up with x equals pi over 6 plus 2k pi over 3. And that's my answer for that one. Again, fairly simple problem. Okay, last one. Last one, this one's a hard one. Now this is just something called the half angle identities. I don't know that we talked about these at all, okay? But essentially, so I'm just going to say, trust me that they were, okay? So this says, find the solutions of sine x equals sine x over 2, where between x is between 0 and 2 pi. Okay, we're just going to find all the solutions like we have every other time instead of trying to bound it. But, so what I want to do is I want to replace the sine of x over 2 with something else. So because I don't want to have the sine of x and the sine of x over 2. So since we have this rule, it says I can do this. I'm trying to make this smaller. Okay. Oh, that doesn't show up very well, does it? Okay. So sine of x over 2 equals plus or minus the square root of 1 minus cosine x over 2. So I can replace that here. So I can say the sine of x equals plus or minus the square root 1 minus cosine x over 2. Now, to get rid of the square root and the plus or minus, I'm going to square both sides. So I end up with sine squared equals 1 minus cosine x over 2. Now I don't want to have both sines and cosines. This is a really complicated problem. I don't want to have both sines and cosines in the problem. So since it's easier for me to change the sine squared to a cosine, I'm going to change it to 1 minus cosine squared x equals 1 minus cosine x. Now, a lot of algebra is going to happen right now. I'm going to do a lot of manipulating to get everything where I want it. And I'm going to talk through it relatively quickly, but I'm going to do it. So we're going to multiply both sides by 2, which means I end up with 2 minus 2 cosine squared x equals 1 minus cosine x. Now I'm going to move everything over. So I end up with, I'm going to move this direction. And the reason I'm going to move that direction is because I don't want my cosine squared to be negative. So I end up with 1 minus cosine x minus 1 plus 2 cosine squared x. I simplify. I can get my multiple bigger. Hang on a minute. I have the wrong. Okay, let's try this again. It's running out of space. Okay, so we'll move this all over here. So I end up with 1 minus cosine x minus 2 plus 2 cosine squared x. So I end up with 2 cosine squared x minus cosine x. Okay, 1 and negative 2 is minus 1 is 0. Now I can factor. Okay, now I'm going to go through this factoring again a little slowly because that's how we had trouble with last time. I'm going to 2 times negative 1, negative 2. Okay, factors of that give me a negative 1, or a negative 2 and a positive 1. So I end up with 2 cosine squared x minus 2 cosine x plus cosine x minus 1. Factor, I can factor out 2 cosine x. I don't know, this shouldn't be a negative anymore. Stupid word. Equals cosine x minus 1. Okay, we're going to imagine this little 1 here. Cosine x minus 1. And when I factor out the cosine x minus 1, I'm left with 2 cosine x plus 1. Okay. Extend. Going, no problem. Okay. So now I can solve both of these. Cosine x minus 1 equals 0, and 2 cosine x plus 1 equals 0. So cosine x is 1, and cosine x equals negative 1/2. Okay. Cosine x equals negative 1/2 at 2 pi over 3 plus 2k pi. negative 2 pi over 3 plus 2k pi. And cosine of x equals 1, that is just 2k pi. And it's another one of those rules that's on the chart. When it's equal to 1, then it's easier. Alright, and that is all I have for you. Please make sure that you watch the video, and I will see you tomorrow, and we will do the homework.